right, so our warm-up is at the top of our note sheet, and it has two segment pictures asking us to find the lengths of the following segments. In geometry, you'll see a lot of pictures. You'll also be given a lot of information in like a sentence. What you want to do is take those numbers and put them on the picture, and that's going to help you a lot throughout the class. So we'll put, it says AB is 5 units long, and BC is 12 units long. And it asks me how long is AC? The whole thing. Who thinks they know? Jax. 17. 5 plus 12 is 17. Very good. The next one, LM, which is the whole segment, which if you can't draw this, just put like a rectangle. Something. Oops, 29. I thought the wrong spot. And LN is 17. How long is NM? How long is NM? Parker? 12. So working in reverse, if we know the total segment and we subtract the smaller segment, what we're left with is the other little segment. Jess?
Now, do people like line segment?
Okay, good question. He said, do we need to put like a segment bar, right?
Yeah.
The answer is no, and that's actually in our notes today, the notation. When you're talking about actual numbers, instead of just a segment itself, when there's a number associated or an equal sign and a number associated with the segment, we don't use the bar. And that's actually in our notes today, so we'll take a look at that. When you're talking about just a hypothetical segment with no numbers, you would call that segment LN. But as soon as you attach a number to it and an equal sign, then we no longer use the bar notation. All right, so today we're looking at finding the lengths of segments. We'll do some with just numbers, which are super simple, hopefully, and we'll do some with algebraic expressions. All right, so a coordinate. A coordinate that we're going to be looking at is just on a number line. So we're not doing an x, y coordinate where we're plotting on the x and the y. We're just doing it on a number line. So this will be the points distance and direction from 0. So distance is the number of units. Direction is whether you're going left if it's negative or right if it's positive. You know how to plot a number on a number line. So for example, point A is 2 units to the left of 0. Point B is 3 units to the right of 0. So how long is segment AB? Again, if this is 2 units long and this is 3 units long, how long is segment AB? It's too easy to volunteer, or we don't want to be heard on the recording. Probably no one will watch it anyway, so don't worry. Jada. 5. So AB is 5 units. All right, so we'll do a couple with numbers, and then we'll start throwing in some algebra. Find the length of AB in this picture. How long is AB going to be? Chelsea? 7 units. We have 5 units to get here, 2 units to get here, so the total is 7. Now, you also can subtract large minus small if you wanted to. If you didn't want to have to count 2, 0, and then over, you can do 2 minus negative 5. And the minus a negative becomes plus a positive, which then would add us back to 7. So you can subtract large minus small. Some students just forget to put the subtraction sign in there, so you would need to make sure you do. All right, congruent segments. You're going to see this symbol a lot this year. This is the congruent symbol. Let me make it a little bit bigger. It's an equal bar with a similarity squiggle on top. Okay. It actually means they're similar and equal is what congruent means. But when we're talking about congruent segments, these are said to be segments that have the same length. They are the same length. We'll also look at congruent angles later, which are angles that will have the same measurement. Now, the notation, this is what Jax was asking about, like the segment bar versus not a segment bar. So if you are using, looking at just hypothetical segments that don't have numbers, we would say segment AB is congruent to segment CD. So anytime you use a congruent sign, you're going to be using a segment bar. And this is when you're referring to actual segments that don't have numbers. Okay, so here is an example. Now notice, these are called markings right here. those markings indicate that they're congruent. Like sometimes you'll see a set of segments and they'll just have like one little hash mark. That's telling me this is congruent to that. They'll have the same marking to show that they have the same length. Okay, you could do 3 or 4 little hash marks, or you could do as many, but you have to have them matching. Okay, so in this scenario, these are actual segments with no numbers, so we would say segment AB is congruent to segment CD. Now when you take the markings away and you give numbers instead, well, we know 2 is equal to 2, right? So these have the same length, therefore they are congruent. Okay, but instead of saying they're congruent with numbers, we'll actually use an equal sign, and we'll say AB equals CD. And that again is when you're referring to actual lengths that are numbers. So this one we would say that AB is equal to CD.
I don't have to write regular squiggly line.
Say again?
I don't have to write the little squiggly line.
No, because we're saying they are equal in length, not congruent. Which they are also congruent, but we're just saying that their lengths are equal right now. You could go a step further and say the segments are congruent, and when we get to proofs, your reason would be the definition of congruent segments. We'll talk a little bit about some of the proofs we're going to be seeing in the next chapter. All right. Find the length of each segment and compare them with a less than, greater than, or equal to symbol. So segment AD, who thinks they can tell me how long segment AD is? AD. Caleb? 9 units. And how about BF? Caleb? 9 units also. So those are equal. We'll say that AD equals BF. We do not put the segment bar on top because again we're talking about numbers, not just segments. See if you guys can do the other two. Find the length of each segment and then compare them with a symbol. Okay, pair share with your partner. See if you guys agree on your numbers and your symbols. If your partner's absent, do it. You guys can do it together. Okay. Let's get some people I don't hear from very often. Caleb in the middle. What did you guys get for BD?
5.
5. Very good. And how about for EG? Ben?
13.
No.
3.
3. All right. Okay, be careful because that would be 8 minus 5, not 8 minus a negative 5 because we aren't rolling all the way to the negatives. And so then, Avery, what comparison did you make?
I made AB is greater than
You mean BD?
BD.
Yeah. Very good. And then, Evan, what did you get for the length of segment AC?
9.
AC.
Oh, 6.
6. Okay. And CE? Evelyn? 5. So again, we should have a greater than symbol. All right. Now let's take a look at some with, oh, maybe I still have numbers on the next one. No. Talk about the actual segment addition postulate. So I introduced this the very first day of school with one of our bell ringer questions. The segment addition postulate is one you'll have to memorize. Again, the number is not important. The name of it is the segment addition postulate. It tells you exactly what it sounds like. You can add segments. Okay. So again, it tells us if 3 points, A, B, and C, are collinear, so they have to be on the same line, and B is somewhere in between A and C, doesn't have to be in the middle, just needs to be somewhere in between them, that we are allowed to take segment AB and add segment BC, and that has to equal the total thing, segment AC. So basically what you did on your warm-up without realizing it, you just added the two that were next to each other. So AB plus BC equals AC. This is a postulate we'll use in our 2-column proofs. So when we get in, I think it's in chapter 2, we'll start our proofs, and you'll see these little T-charts that'll say statement and reason. And you'll actually state something. Your reason could be the segment addition postulate, okay? So this is one thing. Some students like to keep a list of all the postulates on a piece of paper in their binder, just so they have every postulate in one place to study from. As we go, if you want to do that while we're still in chapter 1, it might help. All right, so some that still have numbers. You guys only have one of these pictures, so I'll just hide these other two. We'll just have to erase each time. So it says if AB is 5 and BC is 3, find the length of AC. Who thinks they could tell me the length of AC? Stumping all of us. It's too easy to answer. Evelyn? 8. 5 plus 6. Okay? When they give you one picture for multiple questions, you do have to erase each time or write over it. Now this one says AC is 15. AB is 9. How long is BC? Jackson?
6.
6. And 15 minus 9. Very good. And the last one, if BC is 6 and AC is 17, how long is AB? Danielle? 11. Perfect. All right. Now, let's add in some algebra. Example 3. Now, here's another note. Some students in math don't read this part and they just go straight to the question. Actually, I gave a quiz once where the first question was write a ratio, and it was a word problem. People skipped question 1 on their quiz because they thought it was the directions and they didn't read it. Okay, so just make sure you read the problems, because a lot of the stuff that's in here might not be on your picture yet, and you have to add it to the picture. Okay, so if AB equals 25, so I'm going to go to my picture, and I'm going to mark that AB is 25. This is why I give you worksheets for your homework, because a lot of the pictures you're going to want to write all over them. They did give us these, already written down for us. Find the value of x. Then find AN and NB. Okay? So who thinks they could write an equation to help me solve for x? Michaela.
25 equals 2x minus 6 plus 9.
Good. I'm going to just put it the other way around. Instead of 25 equals, I'm going to put equals 25 at the end. But it doesn't matter. You can absolutely do it that way. All right. Now, the parentheses really aren't needed because we're adding. Okay. But do you see how this looks like the bell ringer question now?
Yeah.
Okay. Now, if we were doing a proof, which you're not doing right now, so you aren't required to do this, but I'm just going to show you what it would look like. Your first line would be to say AN plus NB equals AB, and your reason would be the segment addition postulate. Right now you don't. The question's not requiring it, but we're going to take these and throw them into proof questions in chapter 2, so I just like to do it now so you kind of have seen it before.
Is it postulates in every chapter?
Yes. Especially a lot of them in the beginning. and then you use them throughout the year. All right, then you just have to solve. Now, the reason we're allowed to go from this line to this line is we're substituting in. This was AN, so I'm substituting it in. So this would really be the substitution property. I know we say plug in, but really we substitute, and that's a property that we're allowed to use. And then you would just solve this, okay? So again, you're kind of distributing a positive 1, which does nothing. So the parentheses really go away. So I'm really taking 2x plus x, which is 3x. Now be careful, this is a negative 6, positive 7, get me a positive 1, it's 25. And then we solve, subtract, and divide. We get x equals 8. How do I find the length of segment AN? Caleb?
Substitute 8 for x.
Good. Substitute 8 back in for x. So 2 times 8 is 16. 16 minus 6 is 10. To find the length of NB, plug in 8. We get 15. Now always double check, 10 plus 15 does get me 25. If you were to solve this incorrectly somehow, you would realize you did it wrong by checking your answer just by adding 2 numbers together. Okay, like on a quiz or test, take that time to just add those 2 segments, make sure it equals the given segment. All right, the other type of problem we'll see is a midpoint problem. What do you think the midpoint is? Yeah? A point in the middle, okay? So it is a point in the middle. Now, the formal definition is the midpoint of a segment is a point that divides the segment into 2 congruent segments. A point that divides the segment into 2 congruent segments. That's what the formal definition is. But you are correct, it is a point in the middle. Now, another way that you can see this definition, if you have a midpoint or you take a line that goes through the midpoint or a segment that goes through the midpoint, it is said to bisect the segment. Bisect will be a word that tells you it's being cut in half, equally down the middle. Think of dissecting a frog. If you're dissecting a frog, you cut it down the middle and you open it up and you look at its guts. Okay? If you're bisecting a segment, you're cutting it right down the middle, right exactly in the middle. So anytime you see this word, that's going to indicate cutting in half. Okay? All right, so as soon as you see the word midpoint, R is the midpoint of QS, you want to add markings to your picture. Okay? So QR has to be congruent to RS if R is the midpoint. I put 1 hash mark and 1 hash mark. If you want to put 2 and 2, it doesn't matter as long as they are exactly the same marking. Okay? So as soon as you see the word midpoint, you want to add a marking to your picture. The markings might seem weird to you right now, but we're going to mark everything all year to help interpret what we're seeing in a picture. Okay, so our last few are all algebra problems. Oh no, we have one number problem first with midpoint. Then they're all algebra, and I kind of mixed up midpoint and segment addition postulates. That's what can get confusing when you use which one. Basically, if you see the word midpoint, it's a midpoint problem. All right, so find the lengths of the missing lengths if R is the midpoint. Again, a lot of students won't read this part, so please make sure you're reading. As soon as we see R is the midpoint, we're going to go to our picture and we're going to mark it. If R is the midpoint, that means QR is congruent to RS. Question A says if QS, so if this whole thing is 24, how long is QR and how long is RS? The whole thing is 24. How long is Parker? 12. (24) divided by 2. Midpoint cuts it evenly in half, and the 2 have to be the same number and add up to 24. Okay, then I would erase. My next question.
Excuse the interruption. Mrs. Amos Meyer or Mrs. Garner, please dial extension 6. 6515. Mrs. Carter or Mrs. Amos Meyer, dial extension 6515.
So if QR is 8, how long is RS and how long is QS? Jax?
I had that RS would be 8 as well,
Yes.
and then the whole thing's 16.
Perfect. Because of the markings, you know it's a midpoint. This has to be the same length as this. So if one of them's 8, the other one's 8, the whole thing is 16. All right, now let's throw in the algebra. Again, you have to read the given. M is the midpoint of RT. So what's the first thing I do? Add my markings. RM is congruent to MT. Based on that given. That's the definition of a midpoint that allows me to say that. Okay. If I were doing a proof, I would actually write segment RM is congruent to segment MT. And my reason in the reasons column or justification would be definition of a midpoint. Again, you're not required to do this yet, but it's not going to hurt you to write it down now and get used to seeing it. That's the very first thing you would do from that given statement. So who thinks they know what equation we could write to solve for x? Evelyn?
5x plus 9 is equal to 8x minus 36.
Very good. Now, if you were doing a formal proof, there would actually be a step in between there. So we had that the segments were congruent. Your next line in your proof would actually say RM is equal to MT without the segment bars. And the reason would be the definition of congruent segments. Again, you don't need to be writing this on your own yet. I just like to expose you to it now. So when we get to chapter 2, you're not like, what? But I will re-instruct you then. But technically, to go from a congruent sign to an equal sign, you have to use the definition of congruence. Okay? And then this, of course, would be our substitution property that allows me to substitute in those algebraic expressions. So go ahead, solve for x. Also, plug it back in to find your other lengths and fill in those really quickly. Some of the numbers are going to start getting larger too with the segment stuff. You are allowed to use a calculator on these if you want. Remember, your binder and calculator are due tomorrow, so I'll be checking to make sure that you have a binder and that you have a calculator tomorrow. So make sure you bring it to class. And the only reason we make you buy a calculator is you'll need to do it on homework, which you could use your cell phone. But on quizzes and tests, you don't have enough to lend everyone a calculator, and you can't use your cell phone on a test. So that's why everyone has to buy a scientific calculator. If done correctly, we should be getting x equals 15. Okay? Now, to find the length of the segments, all you have to do is take 15 and plug it back in. 5 times 15 plus 9, what do we get for the length of segment Rn? Michaela? 84. Now, don't just write down 84 for MT, even though it should be. Always check and make sure it actually is, because that will help you find a mistake if you made one. 8 times 15 minus 36, does that equal 84? Yes, okay. So that means that obviously I got this question right because I got the numbers to match. And then we add those together, so what is the length of RT? 4 plus 4 is?
168.
168. All right. Now the next one, we're going to run into a little bit of a problem. What's missing from example 6? Avery? A midpoint? Well, it doesn't have to be a midpoint question. Michaela? A picture. So you won't always be given the picture. If there's not a picture, you have to draw one. So draw a segment, put 2 endpoints and put a point somewhere in the middle. It doesn't matter where you put it. Because they didn't tell me it's a midpoint. If you're just letting me know it's not a midpoint. So if there's no picture, you must draw one. Now you have to also interpret what's what. So it says DS, ST, and DT. So that's telling me that S must be in between D and T. Also, take the given pieces of information and put them on the picture. So 2x minus 8, 3x minus 12, and dt 6. Am I adding markings to this picture?
No.
No, they don't tell you it's a midpoint. What's the equation I would write to solve for x? Michaela?
60 equals 2x minus 4
Good. You're adding the 2 segments. You're using the segment addition postulate, and you're setting it equal to 60. Most of you will put equals 60 at the end. She put it at the front. It doesn't matter. It's property of equality. You can flip it. Okay? And then you just solve. Now, a lot of students in my second period solved this wrong. Well, I'll get you started. We combine like terms. 2x and 3x gets me 5x. What do I get after that when I combine my other like terms? Jada? Minus 20. Negative 8 minus 12 is a negative 20.
I thought you should be the plus.
But a positive times a negative is
You times plus.
distributing is multiplication. So this is like a positive 1. Positive 1 times 3 is a positive 3. Positive 1 times a negative 12 is negative 12.
Oh.
Positive 1 times a negative 12. If you were distributing a negative to it, then it would become a positive 2 negatives, which is not. See if you guys can finish out solving for x. And also plugging it back in.
We could solve it without a picture. We would still have to draw one.
You don't have to, it's not required. Like some people will accept an equal by accident. So we can know what they got for the value of x. Evelyn?
No, 16.
Good, we should be getting 16. And then we take 16 and we plug it back in. What do we get for ds, Parker? Good. And how about for st? Michaela? 36. Guys, we still have 2 minutes. Let's not all jump the gun here. And always double check, 24 plus 36, does it equal 60? Yes, so you know you got it right. Oh, that's ringing early. All right, your homework I passed out to you. You are doing the whole thing. Make sure that you do plug the numbers back in to get your segment length when asked.
So we do.